Hi, my name is Jake Audette. I'm going to be taking the exam today. I'm going to do the first problem. I have it set up on the computer right here. And yeah, let's get to it. Let me just get the phone in a good position. Okay. And my calculator here. Okay. Starting off with part A. Yeah, I'm recording. Okay. Hold on, let me just make sure. I want to make sure you can see the work. Okay, I think you can. Yeah, starting off with part A, it is asking us to find the x component of the total electric force exerted by charge 1 and charge 2 on a third charge, charge 3. We're given the charge. Let me just put my name. Exam. Our first charge is positive 4 NC. At x equals 0, our second charge is a positive, or no, sorry, it's a negative 2 NC. At x equals 6. It is 6 centimeters. I'm going to be putting it in meters because that's what we use. And our third charge is negative 2.5. X equals 4 centimeters, and I'm again putting it in 4 meters. We're going to be using Colombo's law, K equals a 0.99 times 10 to the 9th. We plug in that into our equation. So I'm going to be starting off with our charge 1 to 3, and I'm plugging it in. And we're going to multiply the first charge by 10 to the negative 9. And we're going to multiply the third charge, and it's negative, but this is an absolute value equation, so we're going to make that 2.5 times 10 to the negative 9. And over the distance squared from 0 to 0.04, it's 0.04 squared. And we're going to multiply all this and then divide it. I'm going to be putting that in my equation now. And it comes out to 5.61. 5.61, or I'll round up to 2. 62 times 10 to the negative 5 newtons. And now we got to do the charge 2 to 3, which is going to be, again, K, or Colombo's law, times 10 to the 9th of our second charge, which is going to be 2 times 10 to the negative 9, and 2.5 times 10 to the negative 9. And our distance squared, which 0.06 to 0.04, that's a 0.02 distance squared. And that gives us 1.123, or 1.12 times 10 to the negative 4th. Okay. And Now, I'm going to make the chart or graph in this sense. Plotting our points. The first charge is at 0, 1, and it is plus. Second charge is at 0.06. I'm going to put 6 as in centimeters. And that's Q2, and Q3 is at 4. Q2 is negative, Q3 is negative. Okay. Now, for the first one, from Q1 to Q3, it is a plus and a negative, and that means attraction. And Q3 is being attracted in the direction of Q1, so that means it's negative, because it's going to the left axis. And for Q2 to 3-1, or Q3 to 2, Q3 to charge 3 to charge 2, sorry. They're both negative, meaning that's repelling, and Q3 is being repelled away from Q2, which again means it's being pushed to the left, which again makes it negative. Now we're going to add up both of these. Two negatives are going to make a positive on the inside. But since with both cases charge 3 is negative, we're going to put a negative on the outside. And I'm going to put that in my calculator. That gives us a negative 1.68 times 10 to the negative 4. And the answer wants it in newtons, and it is in newtons. And that is the answer for part A. Part B. There we scroll down. It asks us to find the x component of the force of charge 1 on charge 2, or charge 3, sorry. And so we're basically going to do the exact same thing with different numbers, but only on charge 1 and 3, not charge 2. Okay, so charge 1 equals plus 4, 0. X equals 0. I'm gonna put charge 2 because I know we're gonna need it for the next problem. But for now, we don't need it. We don't know it yet. It's unknown. Unknown. And x equals negative 4, or well, 0.04, because we're gonna put it in meters. Okay, and charge 3, which is what we need, is gonna be 2. Okay, plus 2. C. X equals 4. Positive 4, though. Okay, same thing as before. We're gonna take Columbus, times that to the 9th. Then we take the 4 times 10 to the negative 9. And then 2 times 10 to the negative 9 over the distance, which is 0 to 0.04, so it's 0.04 squared, which, using my calculator, just checking if I got all, okay, yeah, charge 2 is unknown, okay. Yeah, okay, it's for the next problem we need it, because I was wondering why it's unknown. Okay. I think Okay. 8.99 times 10 to the 9th times 4 times 10 to the negative 9. 2 times 10 to the negative 9 divided by 4 squared. We are given 4.5, I'm going to round up, times 10 to the negative 5th in newtons. And I'm going to draw my graph now. And we have a charge 1 is at 0, and it's plus. And charge 3 is at 4, and it is plus. I thought it was. Let me scroll down. Nah, I guess it is positive. Okay. Yeah, positive. Okay. Just making sure. So, they're positive, therefore it's going to repel away from 1, pointing to the right, which would be positive, yeah. Okay, and then the answer on the thing, it wants it in micronewtons, I guess, so it was 44.9. Okay. Moved it from newtons to micronewtons. I guess I wanted it in micronewtons because now the next problem. Yeah, okay, so yeah, it gave us the total at 63 and it gave us in micronewtons. That's why we moved it to micronewtons. But for part C, just checking I'm recording. Okay. Part C, it's asking us to find the x component on the force that charge 2 exerts on charge 3. Well, what's neat about that is we're given 64, if I'm correct, 63, sorry, 63 micronewtons, and we just found out that charge 1 to 3 is 44, so we get 0.9, so we can just subtract that, which gives us 63 minus 44.9, 18.1 micronewtons, and yes, it wants it in micronewtons, so I'm just gonna leave it like that. For D, it's asking us to find the charge of Q2. So I guess we said, well, we're given 18.1. We're gonna have to move this to regular newtons. So the formula, I'm pretty sure, if we just move it around using algebra, would be force of 2, 3. I think the distance, and then divide that by Colombo's law times the charge of Q3, and that would give us, okay, so now we're just going to plug everything in. We don't have Q2, but we have 18, and we're going to put that in times 10 to put that in newtons. And our distance, however, if we look over here, our distance is negative 0.04, and we're going to 0.04, so that's 0.08. 0.08 squared sorry, excuse my language. And then we have 8.99 times 10 to the 9th, and then our charge of Q3, which is 2 times 10 to the negative 9th. Okay. Just gotta put all that in the calculator now. God help me. which gives 6.40, and the answer would be, if it's a charge, it'd be NC, but we need to know if it's positive or negative, and this is positive, but we need to do a graph, and charge 3 is at x equals 0.04 negative, so we're gonna put that right here. Okay, Q2 plus, and Q3 is over here at 0.4, and it is also a plus. So it's going to, Q2 is going to, Q2, since they're both plus, they're going to repel. Q2 is going to push Q3 to the right, making it positive. So this is going to be positive. Sorry for the bad box, but there you go. Equals Q2. That's our second charge. Awesome. Now moving on, we have part E. Okay. Part E, 3 more. It is asking us to find the magnitude of the total electric force exerted by charge 1 and 2 on a third charge. Okay. So we have our first charge, second charge, third charge. Okay, 6 and C on x equals 0, y equals 0.200 meters. Oh, it gave us it in meters. That's nice. And these are the same, so I'm just going to find, since these are the same distance, I'm just going to find one chart. I'm going to pick one of these, plug it in, find that, and I'm just going to times it by 2, because this would make this positive anyway. Obviously, I need to look at what makes it positive or negative, because this is a negative on the chart, but other than that, that's nice. That's a nice thing they gave us. Don't have to do both. And a 0y. Like I said, I'm going to do charge 1 and 3. I mean, they're both the same because there's going to be absolute value, but we do 8.9 to the 9th as we have. 6.00 times 10 to the negative 9 of 2.5 over the distance. This is where it's a little trickier. We have an x and a y, so distance equals, we're gonna 0.150 squared plus 0.200 squared. So I'm gonna go ahead and put that on my calculator. Which gives us 0.25. And 0.25 squared. Now I'm gonna solve this out over here. 2.1, I guess I'll round up 6 times 10 to the negative 6 newtons. Now we make the graph, determine if it's positive, negative, or whatever. And this is where I gotta remember, we have 2, oh, okay, wait, hold on. Just remembered, almost forgot. This right here, our second charge is negative. But I mean, if you were to throw this in the equation because of the square root and the square, it's going to make it, or not the square root, but the square is going to make it positive. But we have Q2 at 6, and that's negative. We have Q1 at 6, and that's positive. And we have Q3, sorry, at 0.15, we have Q3, and it is negative. So, looking at both, Q1 and Q3 are negative and a positive, and it's subtracting it, so it's going to go to the left. But, so making the x negative. And for our y, it's also, again, plus minus, but it's going to attract upwards. Okay, sorry, I completely forgot. Okay, let me just start over for this part. So the x is 0. I'm thinking, sorry, I'm just a little mumbled. So for the charge 1 to 3, it's a positive and a negative, therefore it's attracting. For the x, it's going to attract from Q3 to Q1, and it's going to go to the left, making the x negative. For the y, it's going to attract upwards, making the y positive. And same thing for Q2 on the y. This time it's negative and a negative, but it's going to repel Q3 upwards from Q2. It's going to go up. And since it's both repel, it's also going to repel Q3 to the right, making it positive. Yeah, positive. So we have a positive and a negative. And for y, we both have two positives. These are going to cancel out, and it's just going to leave a positive y. So this is going to stay positive. Now we need to plug in, since it's just y left, plug it into sine of our distance on the bottom, and then our charge, or no, our y coordinate, which is 0.200. Okay, just checking. It is negative, okay. Because I originally put a positive. Okay, yeah. Just making sure that this was negative. Because I originally put positive. I thought it was positive, but I'm going to throw this into the calculator. Which gives 0.08, 0.08, 0.08. And then we are going to multiply our 0.08 by our force, which would be 16 times 10 to the -6 newtons times 0.08 equals 1.73 times 10 to the -7 newtons. But remember, since we didn't do charge 2 to 3, even though it would have given us the exact thing, we just times that by 2, giving us 3.46 times 10 to the -6 newtons. And the answer wants it in, I think it wants it in, it's in micronewtons. So, just put 3.46, pretty sure, yeah. That's what we have a negative, so yeah. And that's it in micronewtons. We're still recording, yeah. Okay. Moving on. To 2 more parts left. Find the direction of the total electric, for part F, we're on part F. Find the direction of the total electric force exerted by Q1 and Q2 on Q3 as an angle measured from the plus x-axis towards the y-axis. Well, that's looking at the graph here. I'll redraw the graph out just so we can get a better look. But we had 6 negative, and we had 6 up here. And then we had a Q1, Q2, a positive, a negative, and we had a Q3 over here at 0.15, and it was negative. Now remember, the x's were, because this attracts, it goes to the left, and this is a negative and a negative, it repels, it's going to the right. Our x's, you could just say, I'm just putting a 1 to visualize it, would equal 0. We'd have x equals 0 degrees for our x. But for our y, we had 2 pluses, and they were on the straight line going up. It's one because this is a plus and a negative, and this is above it, it'd be going up, and this is a negative and negative like last time, it's repelling the Q3 up. And it's on the 90 degree y-axis, making it 90 degrees. So our degrees would be 90 degrees. You could put 0, 90 if you want to do x and y, but I just put 90 because that's what it says in the thing. It just has to put one value. Last part. Home stretch. Okay, it's asking us to find the x and y components of the total electric force exerted by charge 1 and charge 2 on a third small piece of a plastic with charge 3. Express your answer in micronewtons. Okay. Start on. Looks like it gives us. Okay, so there's no unknown. Thank God. Make sure I'm still recording. Move this. Assuming you saw. Okay. Alright, let's get started. Part G. And we're given Q1, Q2, and Q3. 3 charges. Plus 4 at x equals 0 and y equals 0.200. Again, they gave us to it in meters. Thank you. And then we have a negative, and see for this one, x equals 0 and y equals 0. Okay. Can't do plus times 2 this time. I thought we would get 2. Sucks. And we have an x equals 0.250 meters, and y equals 0. Okay. First, let's do charge 1 to 3. But let's do the distance, yeah, because, okay, so it'll be 0.200 squared plus 0.250 squared. Put that in the calculator. Which gives us 0.320 meters. Now we can just plug it in like we always do. Do the same thing. I mean, every problem's kind of the same. Just always comes back to this original formula. Sorry, I wrote that kind of high. And then again, this is positive, even though it's negative here, it's absolute value in this equation. Be kind of complicated if it was negative, and we found out it was 0.320 squared. Okay, let me put this in the calculator 1 second. probably the most tedious part. Just non-stop putting this in to the calculator. These long equations, but it has to be done. I chose this degree. Okay. And it gives us 5.26 times 10 to the negative 7 newtons. Okay. Thinking. We have to do. Because. Well, for this, we're gonna have to, since we have an x and a y, we're gonna have to plug cosine and sine in after I make my graph, obviously, to find the x and y of the force of 1 to 3. Just mapping it up right now. And then we'll do the same with charge 2 and then add up the x's and y's for each. Okay. Well, cos. Oh, well, let me make my graph first for this one, then I'll do that. Readjusting, sorry, ma'am. Making our graph. We have a Q1 at 0.2 meters. Positive. And we have one at 0.25. Our third charge. And that's negative. Well, plus and a negative, as I've said, is attracting, and it's going to attract to the left towards the first charge, making the x negative. And it has an attract in a negative, and it's going to go up for the y. Okay, so we're going to have a negative x and a positive y. First, we got to plug cosine in of our distance, on the bottom over our x. Okay, I was thinking 0. I'm like, that can't happen. 0.25. And our sine, which is our y. This is x, this is y. Just put that there for you. We're gonna do 0.320 on the bottom and 0.20 on the top. And our x is negative, so whatever answer this is going to be negative. Putting both into the calculator now. Gives us 4.11 times 10 to the negative 7 newtons. And it's going to be plus 29 times 10 to the negative 7 newtons. Okay. Now we just got to do all this again for 2 to 3. Awesome. Well, setting it up, force 2 to 3, it's going to be 8.99 times 10 to the 9th. And what's nice is we don't have to do the distance now. We just have 0.250 because we had to do the distance before because we had a 1 in the x, 1 in the y. That's the distance formula. But now I guess we don't. Thank God. Just plug in our stuff. Sorry, not negative. Absolute value of me. Remember that. I'm getting tired. And yeah, 0.250 is our distance right here, and 0 and y, so that's why it's our distance. And now, once again, I gotta put this in my calculator. At least I'm getting faster at it. Alright, 8.63 times 10 to the negative 7 newtons for our force of 2 to 3. Now we gotta just do this part again. What's a nice thing about it though is both our y's are 0, so that makes our sin, that's just 0. Okay, or y equals 0. We do have to do our x though. Before I do that though, hold on, I'm going to do the graph. Our charge 2 sits at the origin, and it is a negative. And our charge 3 sits again at 0.250, and it is negative. Both are negative. Well, our y is 0, and our x is going to be, well, I have two negatives, repels. It's going to repel away from Q3, which makes it positive. Awesome. So then we have positive cosine equals 0.250 on the bottom. And if I'm not mistaken, 0.250. Just thinking right now, because, okay, which would equal 1. Okay. I guess we're just left, I guess we're not multiplying it by anything then. We just have 8.63 times 10 to the negative 7 newtons. So it's just going to go out to 1 because 1 is 0. Okay. I guess we just add them up now because this is the x. So, wow, okay, I really cleaned up. We have 8.63 times 10 to the negative 7 newtons minus 4.11 times 10 to the negative 7 newtons. And then, well, since we don't have a y, our y is just going to be 3.29. So let me calculate this real quickly. Wow, that's just nice. Just cleaned up all nicely like that. I was like, did I do something wrong? 4.52 times 10 to the negative 7. Newtons. I think it wants it in newtons, hopefully, but I'll check after. And then, yeah, I guess I'll write out for the y, but it would just be 8, or no, sorry. It would just be 0 plus 3.29 7 newtons, which just equals 3.29 times 10 to the negative 7 newtons. Okay. I'm gonna write my answer right over here, just because I ran out of space. But let me check. Does it want it in micronewtons? I guess it does. Okay. So answer being fx fy equals 0.452. That's micronewtons, yeah. And 0.329. And that is the last part. I'm uploading now. I I hope I did a chart for each one. If you can't understand what I wrote, I do have really bad handwriting. I can re-upload and try it for my best, but did a chart for each problem, just making sure. Yeah, did a chart for each problem, a graph, and yeah. Again, if there's anything that I messed up with my handwriting or my formatting, please let me know. Yeah, it's an NC. I put NC. I got my units. Please let me know. I will re-upload it if that's a possibility. And yeah, it's my answer for G right here. Awesome. Thank you so much. Have a nice day.